Good morning, good afternoon, everybody. I would like to check if you can hear me all. Just please send me your yes or no into the question panel so I can see. And it is really great to see that so many of you. Oh, perfect! Thank you so much. So you can hear me, you can see me. And now I am sharing the presentation. So welcome everybody. This is a webinar by the iChemist Safety Center on creeping changes. At any time during this webinar, you will be able to ask questions, and I try to answer to those questions. Yes, I can see. Okay, and you can ask questions, and I try to answer to those questions to my very best knowledge. Right. All we are here today to learn from creeping changes. My name is Dr. Zsuzsanna Gyenes, and I'm the Deputy to the Director of the iChemist Safety Center. This webinar is interactive, and if you have any questions, as I said, you just add to your questions to the panel, and then I will try to answer to those questions. Before we start getting involved in this very heavy topic on creeping changes, I would like to start talking about very briefly about the iChemist Safety Center framework. I am pretty sure that most of you are really familiar with the iChemist Safety Center framework. This is not a management safety system, and it is not even seeking for being one. At the iChemist Safety Center, we believe that management of process safety is about having a disciplined framework focused on preventing and control of process safety events. And those control needs to be maintained at all phases of a facility life cycle. And as you can see here that the iChemist Safety Center considers that process safety is fundamentally built on 6 functional areas or pillars. And these are knowledge and competence, engineering and design, systems and procedures, assurance, human factors, and culture. Now, to complete management of process safety, it is also vital to ensure there is a high-level leadership and commitment across all 6 functional areas. I wanted to show you this ISC framework because later on, during the presentation, I will refer to this framework once more. You will see later. What are our objectives for today? I would like to discuss how we can learn from the phenomena and from the cases where creeping changes occurred as an underlying or contributing factor to different accidents. And we need to understand what we mean by creeping changes. Now then, I give you a brief description of the ISC lead process safety metrics, because I will associate those process safety metrics to the cases. You will see how. Then I will go into the details about 2 case studies that I will present to you, and then these 2 cases will actually are from completely different areas, from different industries, and one of them actually is not even an industry per se, but you will see later. Then I will go into the details of what happened, what were the circumstances or underlying causes or contributing factors to that particular accident, and then I will associate those lead metrics as far as I can with those cases, and then we will see about the conclusions. But I think that most of you who have heard me talking before, I like starting my presentation and building it up based on past events, because I truly believe that sharing old stories, old cases, it's really important to get to know more about the phenomena that we would like to explore more. Now, about creeping changes, I have a couple of examples, and very, very briefly, I would like to present to you why I think that these are related to the topic. Now, the first one is the case of the Royal Air Force Nimrod military aircraft. that suffered a catastrophic mid-air fire whilst on a routine mission over Afghanistan in 2006. This led to the total loss of the aircraft and, unfortunately, the death of all 14 service personnel on board. The direct cause was not enemy fire, but leaking fuel being ignited by apparently an exposed hot cross-feed pipe. Now, the deeper causes were quite organizational and managerial. And for instance, between 1983 and 2006, so it's quite a lot of time that we're talking about, a fourfold increase in the number of fuel leaks on this aircraft happened. Now, that escalation happened gradually over these 23 years. These leaks individually were not considered safety critical, one by one. They just thought that it was a one case, and that's it. They didn't consider all together as a chain event. Accumulation of fuel leaks had been unnoticed, resulted in the ignition of a fire and subsequent explosion. There's a greater analysis on this particular accident that highlight many more organizational aspects that I don't want to go into the details right now. Let's see the second case. Here is the King Cross fire on 18th November in 1987. A fire broke out at King's Cross St Pancras tube station in London Underground. The fire started under a wooden escalator serving the Piccadilly line, and approximately within 15 minutes it erupted in a flashover into the underground ticket hall, and it killed 31 people and injured 100. Now, the accident started with smoldering, and the fire had started due to a lit match being dropped onto the escalator. Apparently, according to the investigation, the staff were complacent because there had never been a fatal fire on the underground before. So what could go wrong? Never happened before. I think that most of you already heard this sentence. And had been given little or no training to deal with fires or evacuation at all. And similar fires had happened before, but there was no escalation of the fire. So you can see here already the changes, the patterns behind that. These events happened before, like it was in the Nimrod case. Those leaks occurred during and over 23 years. Now in King's Cross, also these small fires, those occurred. They were called smoldering, and staff had no training to deal with them, and apparently they underestimated the risks. Costa Concordia. This is slightly different because this is the aspect that shows also complacency at a certain level and normalization of deviance. I don't know how many of you heard of Costa Concordia. It was a cruise ship which struck rocks and eventually sank when it sailed at high speed too close to an island in a maneuver called a salute. The reason for the salute was usually to thrill passengers and people on shore at how close the ship can come to the shore. There does appear to have been a history of Costa ships performing salutes over many years. So you can see here also the pattern that it happened over the years. This deviant activity may have been normalized in the company culture, so it was okay, it was accepted. The captain was charged and apparently he deserted his post after he left the ship while the evacuation was still underway. So that was a normalization of deviance aspect. Now, Shell Moerdijk, that you may be really familiar with, that occurred in 2014. 2 severe explosions occurred at the Moerdijk facility run by Shell in the Netherlands, followed by a large fire during startup. During startup activity, as we all know, is a very dangerous, high hazardous activity. The explosion occurred soon after an unforeseen chemical reaction formed between the catalyst and ethylbenzene. Now, ethylbenzene was at the time considered as inert substance under all process conditions. And based on this belief, any potential reaction between two materials during warming up or startup procedure was not included in the risk assessment. In the following years, modifications were made to the plant and procedures involved in this chemical process. So now you can see or sense again those changes that occurred over the years. So for instance, they changed the catalyst. They didn't know the full description and full characteristics of that catalyst, how it performs during startup. They knew about that it was inert during normal operation. However, normal operation is different from startups. And then they changed the plant several times, as well as operating procedures. And apparently during tests of the catalyst, the circumstances during startup were not considered. So that happened very briefly. We all are familiar with what happened at Texas City Refinery in 2005, where an explosion occurred when a hydrocarbon vapor cloud was ignited and exploded at the ISOM unit of the refinery. It killed 15 workers and injured more than 180 others. Now we know that from the investigation reports that there were so many issues here that went wrong, apparently. And one aspect would be that there were releases from that particular unit at least 6 other times when vapor cloud was formed over the previous 10 years. So there was also a pattern that showed that something really goes not so well and not according to the design, not according to what it should be. The procedures seemed to be outdated and not covering all possible critical events, as the investigation revealed. And there was a presence of temporary trailers. Now this is a change, a modification to the original design. Apparently, these trailers had been located in this area for over 30 years during maintenance shutdowns. So that you can see the changes in this respect. And there were, as I said, many other like cost-cutting issues and those organizational changes that contributed to the accident. I hope that I could give you some of with these examples, some of the aspects that we will be talking about here. Now, if you want, you can tell me, what do you think are creeping changes based on what I have just briefly introduced to you, or based on your experience? If you would like to share it with others, then please feel free to type in the question panel. I just leave this with you if you would like to answer to the question. If not, anyway, it won't be a surprise. I will share the answer with you to my best knowledge. But I give you just a couple of seconds so that if those of you who would like to share, oh, okay. Very well. Thank you so much. You already started, yes, organizational change, unnoticed, insidious, unrecognized. Accidents occur over time. Minor changes not meeting requirements for full risk or hazard assessment, but collectively lead to major change. Many small changes which add up to a significant deviation. Accumulation of minor changes over a period of time. No actioning incident investigation actions. Gradual changes to safe systems of work that are not realized by the operator, and so on. Management of change, organizational change. Aggregated, slow degradation. Ooh, thank you. You are really active, audience, I have to say. And I give you here just a second if I find back my, yes. I give you here one possible definition, which could be only one. I mean, you have all very brilliant ideas about what creeping changes are. So there is not a big surprise that I showed you that according to some of the publications, the creeping changes are accumulation of minor changes, as you have already very well said, which often are ignored or accepted as the new norm. So that is what I mean by normalization of deviance. So that's the new norm, it's okay, it's fine. But these changes over time can add up to a big one and could lead potentially to a major incident. Now that we are on the same page, yes, this is another kind of visualization what we mean by creeping changes. I don't know if you have heard of the fable describing a frog being slowly boiled alive. Sorry about the example, maybe it's not that nice, but this is what I can associate creeping changes with. So the premise is that if a frog is put suddenly into boiling water, it will jump out. But if the frog is put in tepid water, which is then brought to boil slowly, it will not perceive the danger and apparently will be cooked to death. I don't know if it's true or not, but this is what the fable says. The story is often used as a metaphor for the inability or unwillingness of people to react to or be aware of sinister threats that arise gradually rather than suddenly. So that's why I thought I would show you this fable so that we see the other aspect. Now, what is the theory? Why is it possible that majority of the accidents are the result of creeping changes? Partially because no industrial sites are static. We may tend to forget about this, that changes are normal. Changes made to the original design, or there are changes due to aging. For instance, changes inevitably occurring during degradation of the equipment over time. And there are, as you already mentioned it really nicely, organizational changes occur in the facility. Plus, the category of normalization of deviance, accepting deviations from the norm, either not following the operating procedures or accepting a new behavior as the new norm. So this is the theory behind. But what are the main aspects, the main features of creeping changes? And obviously, everybody can add to this list if you wish. And I give you a couple of examples just to trigger potential thoughts. Now, the main aspects, I think, are physical degradation, physical changes in the plant and the equipment. As I already mentioned, organizational changes. A very, very significant aspect is altering from the original design, new or modified processes introduced into the system. Relating to aging, for instance, that is also an aspect we have to consider, that loss of skills and knowledge brought about by staff changes and changes in the culture within the company. But then, if we know the main characteristics, I have a question. Why is it so difficult to identify these creeping changes? Because I think these changes remain unchecked because, as you already pointed it out, these are small, unplanned, gradual, and therefore they may not be noticed or they may be ignored, and they can lead to normalization of deviance. Not all of them, not necessarily, but it can happen. You will see that later on, as I promised, I will associate some of the aspects of the creeping changes to the leading metrics, the lead process safety metrics. And therefore, I think it's important that I introduce these two guidance documents that were produced by the iChemist Safety Center with the help of the member organizations. The first one is the lead process safety metrics guidance document on selecting, tracking, and learning. And then there is a supplementary toolkit on a specific metric. I will show you later on how these metrics could be linked to the key findings about those cases. And you will see there is a link so that you can download at any time these guidance documents, those 2 of them, from our website. We have 21 lead process safety metric elements, and these are they are grouped around the 6 pillars or 6 elements of the iChemist Safety Center framework. I don't want to spend much time on this, but you will see the importance of these metrics in terms of creeping changes during the presentation. Now, the first case occurred in an oil refinery, and I will tell you what happened exactly. Now, what happened? That the fluidized catalytic cracker unit was shut down after a power distribution failure in the end of May, and was being restarted after an 11-day shutdown in June. During startup, however, a significant leak of hydrocarbons was discovered by the staff, and vapor cloud formed and then ignited and resulted in a serious fire. Luckily, all the workers escaped before the blast happened, and nobody got injured in this incident. So that is the positive side of what happened. But let's see about the circumstances. And you will see some of the words underlined, and you may have a slight idea why I indicated them underlined, but I will tell you later. Now, the leak was apparently as a result of the failure of a T-piece connection at the base of the debutanizer column, and it found a source of ignition nearby. This T-piece connection originally was installed in the 1950s. So this is an interesting aspect. If you think about creeping changes, and most of the investigation reports, they don't go back in time that far. However, creeping changes could be originated from years and years before the actual big accident occurred. So in this case, this T-piece connection was originally installed in the 1950s. It was correctly specified. However, it was incorrectly fitted, and eventually it was hidden by lagging. Plus, there was no subsequent amendment to the plant layout drawings to identify that change. And then you can ask me the question, but then how can I know that there was a change? How do I know that there was the lagging and there was that you don't have any information from how the T-piece connection was fitted? As I promised, I tell you why I underline these aspects in the circumstances, because those are, I think, those are or could be element of creeping changes already. So there was an original installation, but incorrectly fitted and then hidden by lagging. I could have underlined also the lagging factor, and then the drawings were not updated. What were the others? Since 1950s, sections of the unit had been significantly modified, and prior to these modifications in 1986, changes had been made, and the pipework at the base of the column, and there was a valve. The valve was removed. That was also an underlying aspect here. That change particularly resulted in there being inadequate support for the remaining pipework and the T-piece connection. Between 1996 and 98, the unit had been experiencing considerable difficulties, and apparently it didn't operate consistently. So for 2 years, there were problems with the operation, and this resulted in increasing the number of the startups and shutdown cycles. And that could have contributed to subsequent incidents and due to cyclic stresses and vibration, as we know that there could be due to the fact that this increasing number of startups and shutdowns, which are really dangerous procedures in terms of that you have all the parameters, the running parameters are really high, like high temperature, high pressure, so that degradation of equipment could occur during startup and especially startup really rapidly. I have underlined a couple of examples here as well about series of modifications. The valve was removed, and then the increasing number of the startups and shutdown cycles. Now, what else happened here? 11 weeks before the incident, out of 19 startup attempts, only 7 were successful. Failure of the T-piece connection pipework was probably caused by a combination of the incorrectly fitted T-piece connection, the inadequately supported pipework. Apparently, there was a problem with the safety report as well, because it didn't reflect apparently to the current condition of the unit. There were incidents before, as you can see here, as well as we could see in the previous examples of past events, that there is a pattern of previous incidents related to vibration of the transfer line, even 2 years before the explosion, and those incidents apparently were not reported and or investigated. To make our life a little bit more difficult, there was also a factor that contributed to this chain of events. There was a construction on site of a new facility, and most of the work were subcontracted out of a contractor of the contractor of the contractor. So it was a different layers of contracting out of the activity, which wouldn't necessarily be a problem, because this is what normally operators and plants do, because you need to contract some works out. It is normal. However, in this particular case, the investigation found that there was lack of supervision and lack of following procedures. And now I would like to associate these factors that I already highlighted and even underlined, so that the new facility is being built, only 7 successful startups, safety report didn't reflect the current condition, not investigating incidents before. So let's see what could be possibly the metrics. You can identify more of them. It's not a secret. So if you take the guidance document and then read it through, and then you can identify more metrics if you would like to. So one of the metrics that I chose was compliance with safety critical procedures by observation, and what it means that critical procedures, for example, startup procedures, should be correctly followed. Apparently, those procedures were not followed in this case. Many previous incidents occurred, and there was a prolonged startup on the unit, and that resulted in the ignition of a torch oil vapor cloud. Why it is important? Because apparently the operating procedures that were really solid and were in place in this plant, they were not correctly followed. Another potential metrics could be the open management of change on safety critical elements, and it underlines the fact of the modifications that occurred to the plant over the years, particularly when they removed the valve on the pipework at the base of the column, which originally had supported the pipework and the T-piece connection. That caused vibration and degradation of the equipment. Another potential lead process safety metric could be the number of non-conformances found in process safety audits. As I mentioned, according to the authorities, the regulators, the safety report actually didn't reflect the reality of the condition of the unit, because 1 or 2 years prior to the accident, the revision by the company concluded that the hardware and software controls are in place on the unit are adequate to prevent the occurrence of a major accident. So potentially it was not, unfortunately, it was not the case. And there are a couple of metrics that you can identify relating to culture that I mentioned already, that there were different incidents that occurred prior to the explosion, and they were not investigated or reported. And those eventually resulted in changes, organizational changes. I mean, that those went unnoticed. One of the features of creeping changes, that there are changes meaning that they didn't, or the ignorance, or that they didn't even realize that there were such events that occurred in the past, so they went unnoticed, and therefore they were not investigated. And then the company reviewed, they knew that there was a problem, so they reviewed the unit. They tried to find out what happened and why it didn't operate properly. But unfortunately, those findings apparently were not implemented or communicated properly. That this was case 1 I wanted to present. As I mentioned, the second case will be not related to process safety, and eventually it is a little bit more difficult to identify those creeping changes. However, it is not impossible. I hope that the case 1 already demonstrated a couple of the features and made it a little bit more clear what we mean by creeping changes and what are those aspects. And yes, you may say that it's easier to recognize those changes after the accident happened and after the investigation report is out and published. Yes, I agree. However, we can still learn from these points highlighted in this case, so that when you have your own operation, then you may just think about, do I have this kind of change in my plant? And then that could help to prevent such events to occur. They may still occur, but maybe you can prevent some of those. So they can be useful. I guess many of you are really familiar with the case of the Herald of Free Enterprise. This ship was a ro-ro, roll-on, roll-off ferry. And this is the case that I will show you now. And I try to associate the aspects of with creeping changes. So what happened? The Herald of Free Enterprise apparently took the lives of 193 people, unfortunately, when it sank off port of Zeebrugge, Belgium, in 1987. The ferry was leaving the harbor for Dover when water entered the hold and car decks via the open bow door. Now, the Herald of Free Enterprise passed the port at 6:24 p.m. and capsized approximately 4 minutes later. Even though the ferry didn't sink entirely, as it was in shallow water above a sandbank, there was not enough time, unfortunately, for passengers and the crew to escape. And that's why the high death toll. The bow door, which was left open, was used for loading vehicles. And most ships had divided hulls, but ro-ro ferries tended not to, because of the difficulties of loading their cargo and the desire to maximize loads. So this particular ferry didn't have bulkheads, and actually it was a normal practice on ro-ro ferries at the time. So when water entered the ship, it moved to one side of the deck and therefore became unstable. There was another aspect that is related to a Parliament Act that required such ships to have divided hull, but lobbying resulted in it being repealed. You can argue that this is a particular creeping change, but if something is not happening so that there is a required or desired design that would be safer, and then that decision is repealed, then according to my opinion, and I'm fine if you would like to argue with this, but I think that there is a change which never happened. So they never changed the design. However, that particular not changing the design to be more safe, that is a signal of creeping change. But as I said, that maybe is just my way of thinking. The assistant bosun, whose job was to close the bow doors as the ship left harbor, but actually he had overworked and had fallen asleep in his bunk, and apparently he missed the loudspeaker warnings that they were about to depart. But then there was a bosun on the deck, on the main deck, but when they investigated this case, they asked him why he didn't act and why he didn't close the door. So then he said he didn't consider it was his duty to close the doors. So apparently there was some organizational factor behind about ownership and responsibilities as well. So he didn't consider it. The bow doors that were on this ferry were not visible from bridge, so that the captain didn't see whether the bow doors are closed or open. The first ferries, however, had different types of doors. Those are called visor doors, and that means that with those doors on these ferries, the captain could see from the bridge the status of those doors, whether they were open or closed. But then, as you see, and I should have underlined this particular issue because this is a significant one, there was a design change, so that they changed those visor doors to clam type doors. And eventually it resulted in the fact that those doors were not anymore visible from the bridge. Pattern, again, that sailing with open loading doors had occurred previously to this accident. So it was a known phenomenon, and apparently from the investigations, captains kept asking the management that they need indicator lights to be installed so that they can see if the doors are open or closed. But then apparently their requests had been ignored by the management. Other circumstances was a recent change in ownership. So there was a new company that bought actually the other that bought the company for a few months before the accident occurred. There was another aspect that these ships tend to carry excessive numbers of passengers, even 10 to 20% more than the loading limit. So more passengers carried than they had life-saving equipment supplied on the ship. There was another interesting aspect, in my opinion, that there were 3 crews and 5 sets of officers on the ship, but they were always different people, so that they were appointed to do the job, and it was based on a random decision, so that they just were on the ship for that particular shift. And there was therefore no consistency in the duties. Again, ownership, again, leadership of different roles within the organization. And we can associate leading metrics, although I have to highlight, yes, I know this is not a process safety event in terms of it is not an accident that occurred in a fixed facility or transportation and so on, but this example shows that we can still identify lead process safety metrics or lead metrics with this case if we wanted to. So just think about a little bit widely. When I say conformance with process safety related role competency requirements, I'm talking about roles and requirement of having the right competency. So first of all, from the investigations, personnel were overworked, and so the bosun, assistant bosun, fell asleep in his cabin. They couldn't implement work activities because they didn't have any procedures in place. What else? If we're talking about, and I talked about engineering and design issue, a high number of failures upon demand, that indicates the design issue and need for improvement. That is what the metrics says. The metric says. In this case, the lack of divided hulls is a lack of barrier in place, or lack of that was a problem with the design. And as I mentioned, not following a change in the design with the divided hulls because of lobbying expelled it, then that was also a problem. That was also a change in the design, and as well as obviously the visual doors that were replaced by the other type, the clamp type doors, and apparently there was no assessment behind. Open management of change on safety critical elements could be the change, as I mentioned also here. You can use this metric in the design of the doors. That could have actually required or should have required management of change procedure in place. Failure of primary containment inspection barriers failing on test in a wide meaning. If you would like to associate some metrics to this case. So that was this the pattern of several occasions when ships had left harbor with their doors open, and that captains asked for indicator lights to be installed. So those could be the aspects here. And now we arrive to the part where I would like to show you what specifically what can you do. First, I would like to give you a brief opportunity to collect your thoughts about the two cases, and if you have any questions about those two cases, then please just type them in the question panel, and I will try to answer them maybe later, but still you can think about them. I hope that these cases highlighted some of the aspects about creeping changes so far, because now we have to talk about the part that I would call is so what. So now what we can do. The IChemist Safety Center publishes its safety law on different topics in every 3 months. And one of the topics was on creeping changes, where I just demonstrated one of these two cases and identified key learning points from the case. And then, according to the 6 elements of the IChemist Safety Center framework, I grouped those tips to the operators, meaning to the management, then to the supervisors and process safety engineers, and then to the operators, what they can do to avoid such occurrence in the future. And those of you who may not have time to read such publications, then we also record these safety laws. So you can see the podcast and you can download the podcast as well as the document from our website. So let's go into very briefly. I will go through it really quickly so that you can have the opportunity to ask questions in the end of the session. And also because you can find in the law all of these what can I do, what can you do aspects. So what can I do? What can you do about management of change? If you have changes in management of or ownership, that can actually have large consequences. Incidents occur because some changes had been in place in the system, so that you can make sure that these changes, as a result of adoption of new or altered processes, loss of skills, new knowledge brought into the operation, all of them go through management of change procedure. As I mentioned earlier, every system and its environment changes over time, and so that you can apply strategies to adapt to changing environment, changing in the safety management system. So a couple of these aspects, for example. What else? We talked about design. So as a manager, that you can ensure that audits address changing behavior, to check that the process is carried out as it is originally designed. I would like to highlight it. I know that most of you really are familiar with this aspect, but still I think it is important to stress it. There can be significant difference between how the system originally being designed, especially when we're talking about really old facilities, that obviously that the original design had been changed over time, over these years. And in case there is an incident scenario that was not considered originally in the original design phase, but that scenario is possible, then it needs to be incorporated into the leading metrics program. So that's why I showed you the metrics. How to detect? So signs of change, as we already seen it, really difficult to detect. So if you implement a system and structured process for identifying those changes, then you can detect how the process should operate and what the current status is. So continuously monitoring your system, how it is, how it behaves, what are the changes, what happens, what upsets to the system occurs over time. That gives you some idea. And if you implement leading metrics in the risk management program, that you have clear responsibilities, clear roles, and competency, so then it helps you that if you see that problems occurring, then should be an action plan to ensure that these leading metrics exist, first of all, and that they are actually useful and they indicate when and how they will be checked and have an action associated with them. So it's not enough just to have leading metrics, but you have to understand their application and their use and whether they can cover a particular aspect. If not, then you can identify more of them, but then always feed it back to the system and understand why they are there and whether they are operating well. So that you need to periodically review those lead metrics and update the list in case of a change or in case it needs to be. In terms of incidents, even small changes, even near misses, everything should be investigated. And not only focusing on proximal events, as I showed you in the example of the oil refinery, 1950s we are talking about. So in case of an incident occurring, you can check, and you should check, if the leading metrics that you have selected for the particular unit are in place, whether they are in place, whether these leading metrics failed, and why they failed, so that you can identify the problem to prevent further future incidents and take actions if necessary. As I mentioned, near misses are really good signals that something is going wrong within the system. So you can check those near misses, and you can get information about those accumulating causes that could help identify. What about cost? Cost is a really sensitive topic, I know, but what a manager can do is to make sure that cost cuts do not impact safety and that they do not threaten plant integrity. Easier to say than done, I know, but it is a really significant aspect that we have seen from previous cases. And then also you can make sure that process knowledge is maintained and transferred. Competency, aging factors, meaning physical aging, meaning people aging, people leaving the company, new people arriving, and what I've heard from different industries recently, that the new generation, the new engineers, they are really eager, they want to learn. However, they may not be familiar with old accidents. And when I mention old accidents, I got the feedback that many of fresh undergraduates never heard of Buncefield. So that's what we can do here is to share these lessons, to share the stories. That is an important factor, even if it's not related to cost. Now, coming back to the supervisors very briefly, and process safety engineers, what they can do. And as I mentioned, you can download the document, you can listen to the podcast, and later on this webinar as well. So if you didn't catch one point, then you will have the opportunity later. So that you can make sure, or you have to make sure, that you record trending of leading metrics once they are implemented within the plant, and ensure that the process functions as it is intended based on the original design. And then if you have any documents, if you experience changes, then make sure that you document those changes, so that you write down, you make notes of those changes, and especially the safety critical ones, near misses, immediately after they occurred, so that you have records that you can find later on when you need to when you need to analyze those cases. And as we could see in the one of the case, that if you have a layout drawings, obviously you have of your plant, of your unit, then make sure that those are up to date, and you follow up and record all the changes that occurred on the layout over the years. What else you can do? So when you have a startup going on, it results in significant changes to the unit, and that you should be aware that increasing the frequency of startups result in fluctuations in conditions and increased cyclic stresses on mechanical systems. And also make sure that you pay attention to the signs of normalization of deviance, where operators, contract workers, employees basically might alter from the original procedures for some reasons. They may have their reasonings. It happens, so that you make sure that you pay attention to those aspects, and make sure that the safe operation is really in place. And report and investigate all cases of violations if they occur, and unauthorized changes and workarounds in the system. So this is for process safety engineers and supervisors. But what about you as an operator or contract worker, for instance? This is a topic that requires more attention from the management. That's why the list for the managers are really, really long compared to what we have as tips to the operators. So what can you do? So make sure that you follow the operating, maintenance, and emergency procedures, and do not deviate from them. That is a really critical aspect that I would like to highlight for the operators. And then in case you see something, report any damage or irregular event immediately to the supervisor. That's why supervisors are there, so that operators can immediately turn to them and report if they experience or observe something that is not correct, or they see that there is some potential for a smaller or bigger incident to occur. This is what we always highlight in many forums, that if an operator observes that the procedures cannot be followed because they are really complex, or the wording of the procedure is really difficult to understand, or it doesn't reflect completely on the particular procedure, because these operators know how to do their job on a daily basis, so they are really familiar with the system, the unit, the particular part of the plant that they work on. And it happens that if that they may find that those procedures are not really well worded or they cannot be followed, then they should report. They should just tell the management through supervisors, process engineers, that there is a problem with this procedure, so that they have a free opportunity to tell their managers that they observed something irregular. And we have arrived now to the conclusions part, and I would like to just give you a brief overview about what I have been talking about in this really short time, in this less than 1 hour. So that we talked about the subtle but gradual changes to the system can contribute to accidents. However, if we have lead metrics that could be useful to us to monitor all the processes and what are the changes that are occurring, if we have appropriate knowledge and understanding of what we want to achieve and why. So that is really interesting, that if you have lead process safety metrics in place, then you have to ask the question, why do I have this particular metric? What it is aimed at? Leadership is a significant one. So make relevant stakeholders aware of their own responsibility. And with the necessary care and vigorous monitoring of the system, those changes can be captured in time so that you can prevent a major incident. And that's why I mentioned that when you have this opportunity to learn from past events, and this is one of the aspects of the Seveso directive or the COMA regulation, for instance, in Annex 7, that you have to take into consideration past incidents, even they didn't occur in your facility. And then you demonstrate that you learned the lessons from those accidents. So that is an important aspect, so that you can capture that something happened somewhere else, then okay, this is related to creeping changes, then I have to avoid this to occur. And what I would like to what I would like to highlight is there is a very good publication about the details of hazard identification of creeping changes that was published if I remember correctly, in 2010-ish by the Energy Institute. You see that it's not a new topic, but it's still, there is a good guidance document out there you can get from the Energy Institute on creeping changes hazard identification. In this period of time, I could give you only these examples, and I could tell you briefly and in like an overview about creeping changes. And if you want to go into the details, then you can follow on our lore, or for instance, you can check that publication by the Energy Institute or other literature. But honestly speaking, there's not much literature out there on this specific topic. So I would like to thank you for your kind attention, and also that you actively participated in the questions. So now I try to see the question panel. If you have any questions to ask, then please ask. Also, you have the opportunity later on to send your questions to the safety center at icami.org email address, so that I can answer to those questions later on. So this is the 1 hour webinar that I had on learning from creeping changes. Okay, there is a question about that the creeping changes are in line with elements of risk basis PSM by CCPS. Yeah, could be, yes. I think it's a positive outcome. Is the ICAMI Safety Center process safety model available to the wider audience? Yes, it is. You can visit our website and you can download the ICAMI Safety Center framework at www.icamisafetycenter.org. or you simply go to the iChemie website and then Safety Center, and there you will see this framework, the ISC framework. Obviously, yes, it is available to download for free. Yes. Yes, the webinar will be posted on our website, and if I remember correctly, the presentation will be made available also in PDF, but I will check with my colleagues. So thank you for those questions. And there is a question about assurance. Could you explain more the assurance element? Yes, this is Q&A, yes. Assurance element is actually what I presented about process safety lead metrics. And if you want to hear more about the assurance element, then you can visit our website about the ISC framework, and also you can follow our past webinars on the iChemie Safety Center 6 pillars, and one of them is assurance. So yes, you can get more information, but I highlighted or at least I tried to highlight some of the aspects related to assurance. And there is a comment in the nuclear industry. There is a concept of the design intent, which is self-explanatory. The guardian of this is the design authority, and all engineering changes should be referred to this individual or group. This should ensure the design intent is preserved. Sorry, the question panel is really small. Any further tips on motivating a team or business commercially to act on an individual small ticket item when there are other larger individual issues on the judgment that it may add up to a larger issue? That's a very good question. I think that when you identify those aspects, how much it costs if change to the original design is not followed up correctly, then I think that and then interruption of your normal operation, and then the loss of cost, the loss of money eventually, that could be a good argument. I believe so. And thank you for the comment on the nuclear. That is really helpful. My concern would be here is that we're talking about, as I mentioned, plants that were built in the 1920s, 50s. So that's the challenge now. But I would like to thank you all for your active contribution and interest. We are running out of time. So thank you so much. And you will see shortly the webinar material on the web page. Thank you so much. Bye-bye.